Okay, and then just for fun, take an educated guess. How many electrons each one has? So we talked about the nucleus. You got protons and neutrons in the nucleus. We talked about how to find the number of protons, how to find the number of neutrons. Next phase, how many electrons do they have, right? So those are the three particles, subatomic particles in an atom. You need to be able to figure out how many of each one atoms have. So once you figured out how many protons and neutrons, I want you to figure out, or just take an educated guess, how many electrons. And then we'll go over that and explain that. Okay, talk to somebody near you, double check your answers, and we'll go over it. And Amanda and Talia, get Molly involved, please. Okay. What is the atomic, nuclear symbol here, Emma, for Cl?
35 or 17.
Good, 3517. Molly? No, I can come back to you.
No,
right.
39 and 18.
Hold on, where's, no, Ag, find Ag.
Oh, AG, I was
What's the atomic number? That goes in the bottom left.
47.
47, good. And then what's the mass? We'll round it to a whole number.
108.
108, good. All right, questions on that? Okay, so the number of protons for both. Vanessa, what do you got? 17? 47. Whatever the atomic number is, that's your protons. And remember, those are positive. Okay, I repeat this stuff like hundreds of times throughout the rest of the year because I really need you to remember that. How to find the protons, remember they are positive. Okay, now the number of neutrons. We just subtract these two numbers. So Kara, how many neutrons here? 18 neutrons. Remember, those are neutral. So remember, these two are inside the nucleus, right? So the nucleus for Cl would have a positive 17 charge. Because of those 17 pluses, the 18 zeros have no effect on the charge. Okay, over here. Nicole, what do you think? How many neutrons? 61 neutrons. Okay, good. So why are there so many more neutrons here, and so many more protons? It's because there's more subatomic particles. There's more protons, a higher atomic number. So this nucleus is going to be way more crowded than this one. So here's your nucleus again. All right. What's the charge on this nucleus? plus 47. Because there's 47 positives, 61 zeros, that doesn't affect anything. Questions on those? You will have, well, let's see, you got a test there. I don't know. The next worksheet I give you is going to be this stuff, practicing how to, just more of this. It's a good skill. All right. How do we find the number of electrons? So there's 3 subatomic particles, right? 2 inside the nucleus, so that's your proton, neutron. Outside the nucleus, you have electrons, and where do they live? Is my analogy. They live where? They live on energy levels or shells. Okay, so you have your tiny, tiny, tiny nucleus, and then here's your atom, like the outer boundary. In here, kind of buzzing around like fireflies, are electrons. Okay, they're going all over the place, but they're kind of confined to different levels, energy levels. So outside the nucleus are the electrons. What's the charge of an electron? Negative. Go to table O, please. I'll give you $1 if you can find electrons on there. Just kidding, I can't do that, it's illegal. Teachers and coaches can't use money as motivation. It's illegal. What is it? Is the word electron anywhere on there? No, that's why. What? There's an E for, okay, what's the name of that thing? All the way to the left, what's the name of it? Positron. What's the charge on that thing? Good job. Yeah, positron is the exact opposite of an electron. So what other particle on table O is the opposite of a positron? Beta. Beta is an electron. It makes me crazy that they don't write the word electron on there. I don't think it's fair. You guys need to remember that beta is an electron. Okay? It's the exact same thing. So an electron is 0, -1e. So there's your electron notation. 1 over 1h is a proton, 1 over 0n is a neutron. So eyes up here. What is, besides the charge, right? Electron is -1, neutral, +1. So electrons are negative. So right there, right on the table for you, the chart. What's this mean? What's that 0 up there mean? It's the mass. So an electron doesn't have a mass. It actually does. But it's like 9.28 times 10 to the -24 kilograms or something like that. So it's like 0.23 zeros and 9. So it's basically no mass. But it really does technically have a really, really small mass. You don't need to know that. But this is really small compared to these two. That's what I'm trying to get at. Electrons are incredibly small. Much smaller than these two. Alright? So anyways, electrons are negative. Let's label that. Protons are positive. And we'll end with this concept. If protons are positive and neutrons are neutral, so eyes up here. If protons are positive and neutrons are neutral, it makes sense, I think, everyone seems to get it, that the nucleus is positive for everybody, all atoms in the entire universe. We get that, right? But what about the entire atom? If you have a positive nucleus, but then outside the nucleus you have all these negative charges, well, the positives and negatives are going to balance out or cancel out. So what is the charge on the entire atom? Positive, negative, or neutral? Neutral. And here's why. The atomic number also tells us the number of electrons. So if it has 17 protons, it also has 17 electrons. If it has 47 protons, it also has 47 electrons. So if I use a very simple example back to helium, if this is the nucleus, so just watch, don't write it. If this is the nucleus of helium, there's my +2. Outside the nucleus, I have 2 negatives. There's my -2 from the electron, right? So I got my protons and neutrons in the nucleus. Outside of it is my electrons. Well, if this whole thing, right, if you're looking inside this bigger circle, you have a +2 and a -2 in the same area, they're going to cancel out. So every atom in the world is neutral, but the nucleus is positive. Why? Because the electrons are negative. So I know it gets a little confusing. You just have to think about it carefully. You have to say, all right, there's 47 protons here, but it also has 47 electrons. So the whole thing is neutral. However, you need to remember the nucleus is positive. That's a big thing here and a big difference between the nucleus versus the whole atom. All right? Hopefully that makes some sense. I'm basically out of time. Finish that worksheet. Tomorrow we will go over that and do more with this. Move on. We have to learn about the history of the atom. Who said why?